Hello everybody and welcome to what's probably another experimental new type of video I might start doing. So if there's going to be a brief explanation of what this kind of video is, but if you just want to skip to what the video is actually about, what's probably in the video title, there'll be a timer in the top left that you can just click. Well, not that you can click, but we don't have annotations anymore, but you can skip to on the video, right? You know what I mean, right? Okay, so this video, so this is my game PokeyPoke. Some of you will be familiar with it. I'm not sure how many of you are aware of it as such. But this is a game about a girl with a spear. She can kind of climb, do cool fun things, and it's kind of a bit like a Metroid-y kind of collectathon. You run around and collect cool diamonds, and just have a fun time interacting with the spear and doing cool, difficult little puzzles and jumps and movements and stuff like that. A little precision platformer, collectathon type thing. And I've been working on it for a while, and I've used a lot of the things I've learned in this game as the basis for various tutorials. The ghost recording video that I just put out at the time I'm recording this was based on tech I made for this as a thing for tutorials to show the player how to do like certain stuff, because it's kind of hard to grasp some of the mechanics and stuff in this game. And there's a lot of stuff like that that I've based tutorials on, but there's also been a lot of stuff that I've been showing off and cool effects and things that I've not turned into tutorials, and people have said, oh, is a tutorial on that thing that's in PokeyPoke coming soon? And I've unfortunately had to say no, because I've done things in ways that work, work for the sake of the project and do work, but aren't necessarily the best way of doing things, or I'm not sure are particularly optimal. So I've not shared those as tutorial videos. But what I would like to start doing is start sharing some of those things with you in another way that's kind of disclaimed as not like a properly sanctioned tutorial video, if you will. I'm not claiming that this method is necessarily strong, whereas I feel there's kind of a presumption of that with my other videos. So what I'm going to do in this video is I'm going to talk a bit about this water effect. Okay, I've got this cool water effect that when you jump in it, it's got like a cool boom spring. And I'm not going to do like a full thing where I go through all of the code and explain what it does, but I'm going to just talk briefly about how it works, just so I'm going to have a quick video. And and I suppose it's aimed more at intermediates really, and more advanced developers, as a thing where I just sort of talk about how and why I've done a thing in a particular way, and you can think, oh cool, like I could probably emulate that myself. That probably wouldn't be too difficult to do. So water in the game is only going to be a very simple thing for a lot of different reasons. It's just going to be something you can kind of float in, although there are some interesting interactions. If you float close enough to the surface, you can grab with the spear, you can kind of anchor yourself under the water. But for the most part, the physics of it are just like you float in it. And I'd never done like water in a platformer before. I thought it was going to be way out of like my depth. But what I was originally kind of planning on and kind of expecting to have was just like a box like this that would just be like a line, or maybe like a fixed height variable that would determine where I drew a line, and then a rectangle down, and that would just be water, and I would just change the player's physics when they were in it, and maybe do like some particle effects or something like that. And that was the best I thought I was going to be able to do with water. I figured, I know some stuff about shaders, and I can do sine waves and things in shaders, so I may as well try and do something interesting. So what I've ended up creating is this water body object. I have a layer specifically for, I've got way too many layers, I need to sort this out. I sorted it out once and reduced the number of layers massively, and now there's loads again. So that needs another refactor. But anyway, so there's this H2O object that I can just sort of drag around and mark any real size or shape. If I just do that, run the game, the screen will go black probably, because that's what OBS does whenever I press F5 and run the game. Well, I did that before it even went full screen, then that was interesting. But you can see I come in here and I get this like generic water object, which is really cool. And yeah, if I jump into it, like it's kind of like pulls me up like that. Some other game does that. It's not Minecraft, or something like that, where you can kind of get like pulled up water bodies automatically. I don't know. Similar to something, but either way, when you you splash in from the top, it kind of creates this cool ripple. So how I did this is, first of all, I started with this object, and I started just with creating this box, and it's all kind of done. It was all done through the draw event of this. So what I did was I created a surface. I actually created two surfaces, but the reason for that is a little more complex. I created a surface where I drew an area of the screen from the application surface being the general surface onto which everything in your game is being rendered. I capture that area of screen, so whatever area of screen is there, and I put it onto a surface. Oops. The reason I do that is so that we can then, we've got, that's the background that we're working with, okay? And then I draw, I set my color to be this light blue color, and I draw a rectangle over the top of it, a transparent light blue rectangle, with alpha writing off on the surface for lots of complex reasons involving surfaces and alpha blending. But the main reason is I don't want to overwrite the alpha of the surface all to 0.5, because that's what it would do. I want to blend the color with it, so I want to sort of draw it blended, which is how you would normally kind of draw on top of the application surface, right? So I set that off so I'm not writing to that channel. Then I draw this blue rectangle over the top. I draw a sort of light blue rectangle, light blue line, sorry, 1 pixel down from the top, and a white line right across the top, okay, and that's what creates that sort of little tiny gradient you can see across the top of the water. Okay, and then that's just created the basic water effect, okay. Then I reset the target of the surface, and I set up some stuff here, because a surface, funnily enough, basically acts as its own texture page. Texture page being the thing in memory where you grab all of your graphics, and all your graphics will be on one big texture page when your game is compiled, or multiple texture pages depending how many you've got and so on. And your game, how the graphics card draws your stuff to the screen is it grabs certain areas of that texture page and draws them to the screen at the right times, right? A surface kind of counts as its own texture page. This here is me working out kind of the width and height of a pixel, if you will, or the texture page equivalent of a pixel, which is called a texel. I'm not going to get into the specifics of all that, but it's important for our shader later on. And then I create another surface, and the reason I'm doing this over two surfaces is to do with, if you're doing this in your own game, you probably can get away with only using one surface, but I use a second one because my game is actually, the application surface of my game is bigger than the resolution of the game, okay, which is to allow me to have certain subpixels. Okay, so the actual game space that you're seeing is 640 by 360, right? That's the area of the room that you're looking at now. This is 640 by 360, but you can see, and you can see it in the sphere and how smooth the sphere is when it's rotated. The application surface is way bigger than that. Like if I stick it in the water, coincidentally, that actually removes the subpixels because of the way I'm doing the water like this. But because of that, because I'm using a surface, I have to scale that surface up and draw things to the surface scaled up or scaled down in some cases to make sure that my ending water is the correct sort of pixel dimensions, because I don't want the water to have subpixels in it, even though the sphere does. I kind of want to keep it constrained to the sphere, because it's a little bit of a pixel art sin to even have it in the first place. But I only do it because I think it looks way better on the rotated sphere sprite. For the water, I think the water looks better and more consistent with the ground around me if it doesn't have those subpixels and matches the resolution of the pixel art, right? So in order to get that to work, what I've had to do is capture. So when I'm capturing this, if I captured this area of the screen, 1 pixel here is not actually 1 pixel, right? It's say if you focus on, say, the cursor, the crosshair, right? That pixel right in the center of it is not 1 pixel. It's like a 3 by 3 square, of pixels, okay, on the actual application surface. So when I'm grabbing an area of the screen, I have to grab the area of the screen and then I scale it down by like a factor of 3 when I put it on the original surface. And then this new surface I'm making, the second surface, is to like scale it back up, essentially. And because I scale everything down and scale it back up, that's what causes these subpixels to go away under the water. But I actually quite like the effect it has on the sphere, where it like makes it kind of like blurred and lower detail underwater. I think that's kind of cool. It doesn't really affect anything else because nothing else has subpixels, but it does the sphere, and I actually think it's quite good in that regard, so I'm kind of keeping it that way. So that's why I've kind of got this second surface, but the whole point of this second surface is to kind of draw this at the proper size and everything. So I've like, even when I've been getting a hint, you see this app scale stuff that I'm taking into account, that's specifically to get the correct size of the application surface and so on. So I draw everything to this new surface, but before I do, I actually set a bunch of shader uniforms and I set a shader, and this is where the magic happens that makes the water all wobbly. So if I go to Shrug Wave, the Vertex Shader is just a simple, the default pass-through shader. I do everything in the fragment shader. So you forget about this 2000 long array for now. that's something else, which we'll get to in a minute. These two lines are the main crux of what I'm doing with this wave shader. So I'm taking the y coordinate of every pixel. Like I've made vec2p v-text coordinates, so that's just whatever pixel we're currently rendering, right? Is the easiest way to think about it. And taking the y coordinate of it and adjusting it by a sine wave, which takes in a factor of the number of pixels where pixels in is relevant to px. So based on how far across this, how far across the x-axis this pixel is, we adjust the y of it by a sine wave. So you can imagine that looking like a literal sine wave, right? So it would just go up and down, because as the value of x increases, the sine will do its thing and will go up and then come down and then go up and then come down, right? And then by adding a time factor in there, which is something we get from a uniform float that we pass through in water body in the draw event, we pass through get timer multiplied by a very small value, so like that's getting like microseconds or whatever, right? So we need a very small value to make it work properly. That means the wave will move along because it's going to add x to the y, so it's going to keep increasing the value, so then you're going to get a sine wave that moves along over time. Then what I do, because a regular sine wave, no matter what values we put into it, like I've, all these little 1.5s and 1.2s, little hard numbers that I put in here are just to make it look the kind of height and width of wave that I actually want. A regular sine wave by itself, though, would look kind of very regular, right? Whereas our waves in the game, you see they look kind of odd and like more natural because they're a bit more random. And the way I did that was just make a second sine wave, do the exact same thing again with some different values, and this time subtract time so that the wave is kind of like moving the opposite direction. And that's it. By combining those two waves together, that's how you get the wave effects that we're seeing in there. That's really all there is to that. And that's, at one point, that's where I was going to stop, but then I decided, screw it, we're going to try and make it so you can jump in the water and make it whoosh, and so on. What I did for that is I created an array of springs. So I just created a really big array based on the width of the sprite. So that determines how many springs there are. Shader arrays have to be declared at runtime, or declared at compile time rather, so that's why I've just got like an arbitrary 2000 in here. I don't think, let me know if you know, but I don't think there is a way in which I can kind of pass through like a limit to the array size of this, because as I say, I think it's declared when the game is compiled. I suppose at compile time I could work out the largest one I have in the game and pass that through as kind of a mini way of working it out as like a macro or something. I don't know. But yeah, I couldn't work out a way of making that any better than just putting a really big value in, or the value of like the biggest water body I think I'm gonna have. But yeah, I'd rather buy like a value of like, I think it came to like, I think water division is like 6 out of 8. Okay, that's smaller than I thought. So every 8 pixels, I'm gonna measure a height. And what I did is I created a bunch of springs. Now, this step event here just uses a thing called Hooke's law. I used a tutorial for this myself. I might throw a link in the description for that, of how all this works. But basically, each spring is going to like approach a certain height based on a formula that is a physical law. It's Hooke's law. What it essentially comes down to is that value based on kind of its based on like a given constant, which is like the tension of the spring, and based on sort of its distance from its resting point, which is kind of that 0 height. It will move towards. It will like accelerate towards 0. Okay, so it'll accelerate towards 0, and then it's gone past it. It's obviously still got some momentum, but it's accelerating the other way, and it sort of accelerates back and forth. And then by adding a bit of dampening on that, it wobbles up and down, but then eventually comes to a halt. And then this big long 4 thing essentially just makes every spring kind of pull on the springs left and right of it, so it like takes a bit of that. So then that's what causes the spring to just sort of like spread out. Okay, so it's just a bunch of springs, a huge array of numbers, all just sort of like wobbling between a value above and below 0. And then how that actually comes into the water is I just throw that straight back into the shader and do another adjustment to p.y at the end, based on that spring. And then I use the mix function, which is kind of like the shader equivalent of lerp, to take a height at a given position of the spring, the height of the next position of the spring, the height of one spring, and then 8 pixels along is the height of another spring. But to deal with pixels in between there, we use the mix function, which returns sort of the value interpolated from one spring to another spring by a given amount. And so we work out, like we do some of this stuff here, which works out how many like what percentage we are between from one spring to the next, and then that's what makes it like smoothly interpolate. And then that's really all there was to, well, that's like a catchphrase of mine, isn't it? That's really all there is to it, he says, after like saying a lot of stuff. But yeah, that is all there is to it. So the long and short of this water effect is that I take an area of the application surface, put that on a new surface. I draw a blue rectangle over that surface, a light blue line over the top, and then a white line over the very top to create this sort of top of the water. I then put that surface on another surface for the sake of my specific game and resolution scaling stuff. And when I put it on that other surface, I do so with a sine wave shader that creates a sine wave across that like moves along over time. I then apply another sine wave that goes in the other direction with slightly different values to create a sort of natural kind of rippling effect. And also that natural effect like occurs to all of the pixels, so it's affecting the stuff underneath the water as well. So that's how you can see it affecting the stuff in the background. And then for the splash effect, I have a big array that stores the splashing height of the water, which is all, when it's rippling like this, it's all zeros, so just every 8 pixels, one is 0. When I jump in the water, I just set one of those heights, the one closest to the player, to be like down like 16 or something like that, right? And then using Hooke's law, I make that value sort of accelerate towards 0 with some dampening, so it does eventually arrive at 0. And then have a for loop make that spread out across the other ones by making each array kind of pull on one another. And then I bake the results of that array back into the shader. and using a mix statement I can blend each point from one to the next in terms of its Y position. There's obviously a lot of key detail I missed out. This isn't like a full-fledged tutorial for a lot of reasons. As I say, it's not necessarily even the best way of doing it, using lots of different surfaces like that. It's kind of slow, but it's an effective method, and it works for me. I like being able to just sort of plonk one of these water things anywhere in the game and have them just sort of work. I think it's quite cool. There are some issues I have with it when the water gets really big. Sometimes values at the far right get really weird when I jump in the water and look kind of glitchy. But with the right sizes, it all kind of works. So I'm not really going to see those bugs as actually being a problem, because I just won't have areas like that in the game. So yeah, I think it's a really cool little water effect. I've had a lot of the code on the screen, so just wish you can copy that and look into it in more detail if you want to. This isn't a tutorial, it's just how I did a cool thing in PokeyPoke. Hope you enjoyed that, guys. I'll catch you next time. A huge shout out in particular, and in no particular order, to Andrew Gilbert, Arthur Kyle Vanderlei, Bowser the Dog, Bertie T, Daka Dondigo, Dan, Eric Matthew Hibbs, James Grumley, Jason McMillan, Kimo Savalampi, Malcolm, Mark Lintz, Matt Coate, Michael Ward, Mike KB, Owen Morgan, Patrick Guffey, Penguin Muffins, Robert Churches, Rovan Darlin, Run, Stephen Hagen, Tobias Scholten, Turtle Time, Zephyr Flame, and Zinan May. Thank you all so much. I hope you enjoyed this one. I'll catch you guys next time.